All right, so back again here. Let's try another question. Let's give it a moment to make sure that the stream is live and the audio is working. 1, 2, is live and the audio is working. It's working. Very good. All right, so next question is just a few seconds here to move around. Check if word is valid after substitutions. Okay. So here we go. We'll refresh this, close this. Okay. So the question is, check if word is valid after substitutions. Given a string s, determine if it is quote unquote valid. If it's valid, a string s is valid if starting with an empty string t equals empty string, you can transform t into s after performing the following operation any number of times. Insert string abc into any position in t. More formally, t becomes t left plus abc plus t right, where t is equal to t left and t right. Note that t left and t right may be empty. Turn true if s is a valid string, otherwise return false. So ABC, ABC is true. Start with the empty string, insert ABC, and then insert ABC somewhere. ABC, AA, BC, BC is valid. Okay. And then ABC, 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 AB, AB, CC. Right? We get ABC, go to ABC, 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 ABC again, and then insert ABC in between the A, B, and C here. Here, false. It's not possible to get ABC, CBA using the operation. Okay. String is the size about 20,000, and it's going to be letters A, B, and C. Okay, this is an interesting question. I don't know the solution. Basically, you're going to go backwards, right? So you have to go backwards from the result and determine if whether or not this algorithm can generate this string. Okay. Not so obvious how to do this. I don't know the answer immediately. I have to think about it for a little bit. I would say probably some kind of stack-based solution is the way to go. Basically, wherever you have an A, you could maybe put strings ABC onto a stack. And so whenever you see an A, you would push an A onto the stack. And then when you see a B, that goes on top of the previous A to become AB. Then you see a C, and you could pop that ABC. Then you could push a B and a C to pop that A. Is it possible? Yeah. And basically, if you try to push something other than a B on an A or a C on a B, then you return false, right? So when you push ABC, now when you try to push C, or C into the empty string, yeah, it can only be A's that get pushed when it's empty as well. So I think that's probably the easiest way to do it. We could try it that way. I'm pretty sure that's because it's basically, it's kind of like a recursive thing. Not recursive, I don't know. I'm not sure exactly how to express this, but I think that's a correct solution. I don't know how to prove that though. But I'm pretty sure it's correct. Let's try that. Stack, string, st, const, char chs, if st empty, and ch is a. So there's like 3 cases, right? Okay. So we see A if st is empty, or yeah. Actually, I think you can always push A. You can always push A. think that always works. Then when you say B, if st is empty, or st.top.back is not equal to A, return false. st.back, or top rather, dot pushback B. Or you just do, it's probably better. And then if it's empty or the back is not equal to B, return false, otherwise push B on the top. Something like this. We could try this. I think this is correct. I could be wrong. I didn't really prove it. A, B, C, A, B, C. So, actually, you should pop back. I forgot about that. Don't even push the C on there. You just pop what's there. Yeah, let's just try a bunch of different strings and see if it, just kind of fuzz it and see if it works. So we could do, it's at least size 1, this S. So let's first try just single characters. It's kind of an edge case. And we'll try a few other things. Yeah, it'll take a little bit of time to test it because, oh, okay, it's wrong at A. True, expected false. Okay. Yeah, good thing I tested it. Should just always be false, I think, if it's 1 character. If it's less than 3 characters, then just return false. We don't really need to check this. It's just always false in this case. Don't need to make things too complicated just for that. Actually, no, I do need to handle that case properly. That's what I need to do. Everything has to be paired up and empty. Yeah, because you can end up with like ABCA. Or ABCAB. Yeah, these need to be handled properly. So if the stack, there's still something on the stack afterwards, then it should be false. Okay. Let me try some other random strings just to see A, B. Try some stuff. There might be an edge case, some kind of test case that I don't realize that this doesn't work for. It fails on. Let me try to prove that it's correct. Actually, let me try that. So, to try to prove that it's correct, suppose you're given a string of this kind, right? Then there has to be an A somewhere to start with, right? Because either you have ABC in the beginning or you have something inserted either in between A, before B and C, or or something inserted after A. So you're always going to start with an A. Excuse me. Now, if you have just ABC and then another string of this kind, then this should work recursively in that case, because you'll just push ABC onto the stack, AB onto the stack, and then pop AB when you see a C. the next possibility is that you inserted recursively a similar kind of generated string in between. It could be between A and B, or it could be between B and C. If you inserted this recursively between A and B, then you'd push A onto the stack, and then assuming this works for that recursive string, you would end up with A on the stack and then B and C, and you'd push B and then pop C, and you'd end up with an empty stack at the end, and it would correctly identify the string. The next case, same thing for A between B and C. You would push A and B onto the stack and then correctly process the string recursively, and then pop A, B, and the stack would be empty. Okay, those are the only possibilities. You could either insert before A, between A, B, between B, C, or after C, right? And I kind of handled those cases. That's sort of the last two positions are kind of symmetric in the first case. Now, that'll return true correctly in those scenarios. It will also return false correctly, because if this is not one of those strings, then obviously recursively it'll return false and return false in total for all those cases. But also that would mean then I didn't start with a string ABC and insert something in between. So if I had something other than ABC, well, the only characters you have available are A, B, and C, number one. Number two, yes, if you don't start with an A, it'll return false. Right, does that correctly. Because the stack is empty, and you're looking at a B or a C, it'll return false correctly there. Let's say it starts with an A, but then the next character, again, if the next string is not what we're looking for, then it'll return false inductively or recursively. If the next character if it starts with a B or a C, so let's say it starts with an A, the next character needs to be a B or a B after a string that passes. If it's not a B, then if it's another A or a C, it's not clear. So what can happen is there could be multiple A's, but then the stack won't be empty at the end. So that case is handled correctly. And so if there's a B, then we're okay. We continue. If it's not a B, if it's another A, then we have the issue with the stack. Basically, we assume we recurse. If it's a C, then we return false, right? Because what's on the stack is not the A, not the B rather. It was an A, not a B. And then finally, we're expecting either another recursive case or a C. And if we don't see a C, we see a B. Then again, we have a B on the stack, and we see another B return false. If we have an A on the stack, we assume it's a recursive case. We see a B, and when we see a C, that's what we want to see. So kind of not obvious, but I think this is correct. We'll see if it works. Yep, got it. Okay, very good. All right, so the proof is not that easy. Proof is like a whole bunch of stuff going on, but it works. Let's do submit it 5 times, and then stack-based solutions, fine. So things of that nature that have like recursion involved, basically you can kind of unravel the recursion with a stack. Typically, you can kind of go backwards. So submit this 5 times, and then go to the next question. What I'll do is I'll stop the stream and restart it with a title for the next one. There may be an easier way of doing this, by the way. You probably don't need to use a stack. You could probably use, or you don't necessarily need to use a string. You could use actually a stack of characters might be actually better, because you could just replace what's at the top of the stack with the appropriate character. So you could probably optimize this just slightly if you just use a stack of characters rather than a stack of strings, but this works too. This is fine. All right, so let me go to the next question. So this is a good one. Next one is check if maximum consecutive one's 3. Okay. So yeah, thank you for watching. If you like the stream, don't forget to follow, and I'm gonna restart, go to the next one now.